So let's get started with activation functions. So I'm using only NumPy, you should all be familiar with that. And let's get started with the sigmoid, which is the classical go-to. It's been there for many, many years. And so it transforms the data into probability between 0 and 1, which help us to know whether we want to activate or not the specific perceptron. And we're going to use its derivative because we do backpropagation, as discussed in the previous video and will be discussed later. And so the sigmoid is very simple. It looks like this, as we can see. By minus infinity, we approach 0, and when x goes to infinity, we approach 1 on the y values, and those are translated to probabilities. The function looks like this, and its derivative is this dotted line. And just a quick note, because you might see this activation function called tanh, this one. So you can see the green line over here. This is taken from Wikipedia. This is just a variation on the sigmoid. So this is just so you know. And so, as said, the sigmoid is just the one taken from logistic regression that you've probably encountered earlier in 156. So it's just a 1 over 1 plus e to the minus x. So that's it, as simple as that. And its derivative is the function. So imagine that this x is this sigmoid function times 1 minus that function. So this x, let's just do it here for clarity. It's just the function called, this is not really code that's going to work, but it's for the purpose of this tutorial. So just a block above. So that's it. That's the derivative, and it's going to be seen here as well. And its graph is this one. So what's considered the golden standard is the ReLU, but before that, if you're interested further in how to achieve this derivative, I just wanted to point you towards this really cool resource. I'm going to put the link in this notebook as well, so you can go and walk through it. And this guy Nick just derives the derivative, which is quite useful. And we can see here just what I explained, that we take the function s of x here, and its derivative is the function times 1 minus the function. And you can just walk through it and you'll see the exact thing if your calculus memory is not as great as you would want to. And so that's the sigmoid. ReLU is what's considered the golden standard that people use nowadays for computational reasons. And I think it's just a pretty cool and nice way to deviate back to 110. And so ReLU is as simple as the higher value between 0 and x. So it looks like this. And as you can tell, its derivative is a piecewise function. This is the function. It looks like this, of course. I just made it for you with Grapher. So you're welcome to play with it. It's so simple that it's almost funny. But what we can achieve learning this function is how to do it best practically with Python. So all the ways that you see over here, all those ways are correct. And I found this pretty cool blog post that you can go and read through that times those different options. So people discuss it on Stack Overflow, and I think it's cool, so I voted it up. And you can see that 2 options are plausible for big O y's, and it's the fancy index, so this one, but we should consider very high variation in computation, so 7 rounds of 10 loops, right? So like 70 rounds. And you see this is like the mean of the milliseconds. And I decided to go with something which takes a bit more computational power, but with much lower deviation, because I don't trust this fancy index as much. So I just put it here so you can learn about the different options if you want to strengthen your Pythonic muscle. And I went with this one. And the difference between this and this is that this version happens what's called in place memory-wise. So those are the two activation functions we need for this tutorial. I hope you find it useful. Here's the link I promised, and have a good luck with the next video.